Hey everyone, welcome to today's video. Today we'll be working on an AP Calc BC free response question. This one comes to us from the 2016 AP exam. It's question 5. It's a non-calculator question. So this is what we'll be working on today. So a couple of housekeeping things. So if you want to know where I get these questions from, there's a link to them in the description so you can find this question and many more. So you can check those out at your leisure. Also, if you'd like to follow along a little bit more closely with what part of the question we're working on or what particular concepts we're covering, there's a table of contents in the description with timestamps, and it should also be reflected in the time bar of the YouTube video here and at the bottom of your screen. So if you'd like to follow along with us that way, please do so. And yeah, if you like what you see, please do subscribe. And if you'd like to see more videos like this, drop me a comment. Let me know what your thoughts are. All right. With that, let's get solving this question. All right, so let's see what we've got here. So we've got this funnel here. Right? We've got it's 10 inches tall, and it has circular cross sections. And more importantly, though, we're told that the radius as a function of height is given by this equation here. So r of h is modeled by that. Okay, and of course, the units of r and h are in inches. Okay? First thing we're being asked to find the average value for the radius of this funnel here. Okay, so we're looking for average value, and that, of course, is just given to us by the following formula. So average radius is basically going to be the integral from a to b of r of h over b minus a, where b minus a are just our two endpoints for whatever interval we're interested in finding this average value over. Okay, we're interested in finding the average value for the radius across the entire height of the funnel, the entire length of it. So we're interested in looking at this interval from 0 to 10. Okay, so what we're going to have is the following. We're going to have, come down here, we're going to have the integral from 0 to 10 of r of h, which is this function here, 1 over 20, 3 plus h squared, dh, over 10 minus 0, which is just going to be 10. Wonderful. Now, before I actually evaluate this integral, I want to do a couple of simplifying steps just to make everything look a little nicer. Firstly, I want to bring this 1 over 20 up to the front of my integral, and then I want to turn this dividing by 10 here, I want to turn that into multiplying by 1 over 10, right? Instead of dividing by 10. Just to make this look a little bit nicer, so I don't have any hitches with my integration moving forward. Right? So if we do that, I will get 1 over 10 times 1 over 20 times the integral from 0 to 10 of 3 plus h squared dh. And now we can just go ahead and integrate that. Right? So firstly, though, these two things would be 1 over 200. Just multiplying the fractions there, and then we would just have to integrate that guy there. Okay? So we'd have 3h using an inverse power rule, remember, plus h cubed over 3. Right? Add 1 to the exponent, divide by what you got there. Okay, and we're evaluating this from 0 to 10. Okay, so if we do this, what this will eventually come out to is just going to be 1 over 200 times, plugging in 10, we will get 30, 3 times 10, plus 10 cubed is going to be 1,000. Right? So we have 1,000, because 10 cubed is 1,000, divided by 3, minus what we get when we plug in 0. When we plug in 0 here, both these things are just going to go to 0, right? Because 3 times 0 plus 0 cubed over 3 is just 0. So we just subtract 0, and that's basically what we got. Okay. Awesome. And now we can just tidy this up a little bit more, and I think we'll have our final answer. So 30 is the same thing as 90 over 3, right? So this entire thing would just be 90 over 3 plus 1,000 over 3, which is just 1,090 over 3. Yeah. And then we multiplied by 1 over 200. So what we're going to be left with is 1,090 over 600. And that cancel out, so we're just left with 109 over 60. And that would be our final answer. And of course, this would have units of inches. That's the first part there. Sweet. So now let's see what part B has to say. So part B is asking us to find the volume of that funnel. It's asking us to find the volume of that funnel. So looking at this shape up here that we have, looks a little daunting, right? Because this funnel here doesn't really conform to any of the traditional shapes we know to find the volume for. Like it's not really a cone, not really a cylinder, so it looks a little bit tedious to deal with. However, notice that since we're told that these are circular cross sections, right, we can use something called volume by revolutions, which is centered on this whole idea of having a circular cross section, right? So basically, if we know what this radius is as a function of height, we are basically going to revolve it around the central axis here and use that to find the volume, right? And to do that, we basically need to apply this formula here. Okay? So to do that, we need to apply the formula here. But to recap, we're doing volume by revolutions. And that is given to us by this very nice formula here, which is pi times the integral from a to b that we're interested in of r of h squared dh. Now, normally, setting this up would be a little bit more complicated normally, given a regular Cartesian problem. However, here we're already told very conveniently what r of h is, so we can just go ahead and plug that in, and we'll have our answer. And of course, we know that r of h is equal to 1 over 20 3 plus h squared. That was just from above. I didn't want to have to keep scrolling back up. Right? So that's basically what our formula is. So let's go ahead and do this now. So the interval is going to be from 0 to 10. So we'll have pi times the interval 0 to 10 of this entire quantity squared. So we'll have 1 over 20 times 3 plus h squared. This entire thing squared dh, and we just need to go ahead and integrate that. Okay. So first thing we want to do, let's actually go ahead and distribute this squared term to everything, this squared thing term to everything. So what we'll have is we'll have this first part stays the same, but we'll have the integral. This will be 1 over 400, because 20 squared is 400, times 3 plus h squared, the whole quantity squared dh. Cool. So unfortunately, we do have to FOIL this out. It will look a little bit ugly with h to the fourth term and things like that, but it's the easiest, most straightforward way to integrate this. Right? In addition, what I want to do is I'm going to take this 1 over 400, bring it up front so that it doesn't cause us any problems in the future. Okay, so we'll have pi over 400 times integral still exists, it's still going to be the same, and we just need to FOIL this out. So to FOIL this out, we'll need to apply this identity here, which is a plus b squared is equal to a squared plus 2ab plus b squared. If you remember, this just saves you the trouble of having to actually go through and multiply everything, do the entire foiling process. It just saves you some time there. So we'll have 9, which is 3 squared, plus 2 times 3 times h squared, which is going to be 6h squared, times h squared squared, which is going to be h to the 4th dh. Okay. Cool. And now we just evaluate this. We just integrate this and evaluate. Once again, we're using a reverse power rule, so that does not change. So we'll have over 400. This would now be 9h plus, and this would now be 6h cubed over 3, which is going to be 2h cubed, right? With plus h to the 5th over 5 We're evaluating this guy from 0 to 10. Okay, so let's plug stuff in. So first thing we're going to get is we're going to get 90, because 9 times 10 is 90, plus 2000, because remember 10 cubed is 1000, plus h to the fifth, so it's actually going to be 100,000 over 5. So 100,000 over 5 is just going to be 20,000. Yeah. And that's basically it, right? So, and then of course we could subtract 0 again, because when you plug in 0, all of these terms just go to 0, so we'd subtract that again, and we go from there, right? So let's add all these together. So 20,000 plus 2,000 plus 90 is going to be 22,090. So this is just going to be, yeah. And the answer is just going to be 400. And that cancel. So what we're eventually left with is 2,209 times pi over 40. And the units for this would be cubic inches, because it's a volume. That right there would be our final answer. And that's part B. Sweet. So that's 2 down, just 1 more to go. And there we have it, that's part C. So part C asks us if the funnel containing liquid, so now the part C tells us that we have some liquid in here and it's draining from the bottom through the little hole there. And it says that at the instant when the liquid is at a height of 3 inches, and it tells us that at this instant the radius is decreasing at 1/5 of an inch per second, and it asks us what is the rate of change of height at this particular instant. So as you can see here, we have the makings of what looks to be a related rates question. Right? So we'll need to do a related rates question here. So to give us some space, I'm going to go ahead and clear out the rest of our work here, and we'll start this fresh. Right? So the first things we want to do is we want to establish our general picture and our snapshot picture. So this guy right here is going to be our general picture, right? Because that's basically all the information. There's no real time-independent information here that we're told, right? Everything is only true at one specific point of time. General picture only contains things that are true at all points of time. So that's what we've got there. Next thing we want to do is we want to draw our snapshot picture, right? Or what's happening at the instant when h equals 3 inches, right? So we could draw ourselves a little funnel here, and what you kind of see is that when this height is 3 inches, this radius, we don't really know what the radius is at that point, but we do know that at this particular instant, dr dt is going to be negative 1/5 inches per second. So why is that negative? Well, that's because it's very specifically mentioned in the problem that it's decreasing, right? So that's why we give it a negative sign. Okay, so that's basically our pictures, and of course we know that we can state our goal real quick, right? So we know that we want our goal. So we want to find dh dt. Right? We want to find how fast this height is changing with respect to time at this particular instant. And we want to find this, of course, at this instant when h is equal to 3. So the next thing we want to do is we want to set up our equation. Right? So usually when we do a related rates question, we look at volume. Right? Usually when we do this kind of a related rates question, we usually use a volume for our equation to relate R and H. However, very nicely, we already know how R and H are related with each other, right? So we don't even need to bring in a volume here because we already know how R and H are related. So we can just use that equation right there. So we know that r is equal to 1 over 23 plus h squared. All right, so our next step would then be to take the derivative of this guy with respect to time. In other words, we want to make the equation move. Right? So we take the derivative with respect to time. And one point to note, right, is that t is independent of either of these two variables, right? So we're going to need to use implicit differentiation here. We can't just use regular differentiation. Okay? So what we'll have here is on the right here, we'll have a dr dt, right? And then this side, we can just differentiate what's inside here because the constant doesn't really affect that. So we'll have 1 over 20 times 3, derivative of 3 is just 0. So we'd have 2h times the guy we're really interested in, which is dh dt. Okay. Awesome. And now let's do a quick spot check and see if we know everything that we need to know to actually solve for dh dt here. Well, I know what dr dt is, right? That's going to be my 1/5 over here, and well, really, it's going to be my negative 1/5 up here, right? So it's going to be negative 1/5. I know what my h is, right? That's just going to be 3 up here, and dht is what I'm solving for. Right? So all I have to do now is just plug in my information, do some algebra, and we'll be done. Okay. So we'll have negative 1/5. Again, don't forget the negative. That's pretty important. This is going to be equal to 1 over 20 times 2 times 3 is just 6. So we'll have 6 times dh dt. Okay. Now to solve for dh dt, I'm going to multiply both sides by 20 and then divide by 6. So 20 divided by 5 is going to be 4. 4 divided by 6 is going to be 4/6. So my final answer is going to be dh dt is equal to 4/6, or in other words, 2/3. Sorry, excuse me, that should be negative 2/3 because we have a negative sign there. It's going to be negative 4/6, which is going to be negative 2/3. And this is going to be inches per second. And that right there would be our final answer. Before we wrap this up though, let's just go ahead and quickly verify that this answer makes sense. Okay? So if we come back up here, notice that we're told that radius is decreasing, right? And radius decreases as we go down this funnel here, right? In other words, radius decreases as height decreases. So if our answer is correct, it should be negative because height is decreasing as radius decreases. Does that check out? Well, yeah, it does check out. Our height is negative, which implies that this height is decreasing. So that does make sense. So we are good to go. And that brings us to the end of this video. Thank you so much for watching. I hope you found this helpful. And yeah, best wishes for your future studies. If you found this video helpful, please do like, share, subscribe, leave a comment, and check out some other videos. See you next time!